And welcome to chapter 3, which is VLANs. So basically today we'll be talking about how we segregate a switch into virtual networks for giving us control on how layer 2 traffic behaves. And it also enables us to use common resources for different networks, and this allows us to have efficient transport protocols working within the infrastructure and giving us more bang for our buck, basically. So we'll be looking at what are VLANs, how they work in the switching environment, how we configure them, how trunks are configured, and what trunks are, and then the protocol that controls trunking to make sure everything works. So we'll kick off with the definition of a VLAN. So traditionally you would have a separate network for each floor or department, and that was very inefficient as far as cost and for our networking protocols as well. So with the ability to create virtual networks within the switching fabric, we provide segregation between the different groups. This enables us to have people located throughout the business, not within the same physical location. So a HR person could be on the first floor and the second floor, or a different area of the campus or whatever it is. So it provides greater flexibility with people, moving people around, and rather than having them just confined to their department infrastructure. So the benefit of that is it provides us with more flexibility. We can manage where our broadcasts go, and our multicasts and unicasts can also be isolated to the appropriate VLANs. Now, each network, as you should remember, needs its own IP addressing range, and this is the same with VLANs. Because they're separate virtual networks, they have to have their own individual IP addresses, and by segregating our network into smaller portions with VLANs, we reduce the size and impact of broadcast domains. So by creating multiple virtual networks, we reduce the size of the broadcast domains, which means we have more broadcast domains but smaller in size. We can provide better security of the traffic, because only the machines that are supposed to see the traffic will see it. So you keep your departmental traffic separated, even though it's using shared resources. We have greater efficiency of equipment utilization, which improves the overall cost of the network to deploy and maintain. Generally speaking, we have an increase in performance because traffic is restricted to only those areas that it needs to go. So less traffic means less congestion, which improves the bandwidth available for the proper traffic. It also makes the management of our network simpler, because we can control what resources are available to each particular area more easily. Each switch comes out of the box with a default VLAN, and for Cisco that is VLAN 1. It is the default VLAN, it is the native VLAN, it's the default management VLAN, and it cannot be deleted or renamed. So don't use it. Alright, so when it comes out of the box, every port is already assigned to VLAN 1. It's active, and because it's default, everybody knows it's there. So if you don't have any ports assigned to it, you help secure the network, because there's no active ports, therefore anybody trying to hack the system can't gain access on VLAN 1 to anything within the network. So from a security standpoint, it is best to remove your ports from VLAN 1 and assign them to actual functioning VLANs. Now, what's the different types of VLANs? We have data, which is our general purpose term. So all user-generated traffic, such as emails and web traffic, and that will go across a data VLAN. Now, a native VLAN is a definition of what doesn't need tagging when it goes across a trunk. So we'll explain what trunking is and the protocols and how it works in a little while, but basically a native VLAN doesn't have tags across a trunk. Non-native VLANs all get a tag. Management VLAN is the VLAN we use to connect remotely to the switch for management, and we typically have the default gateway and everything set up for this switch virtual interface. So we give the management VLAN a IP address so we can access that switch, and generally we have this on a different virtual network compared to the rest of our data VLANs. Voice VLANs is a little bit unique in that it's a hybrid, if you like, within the switching fabric. So you have an IP phone connected to a port, and then a PC connected to the phone. So effectively, we're saying this port is dual function. It's doing voice and data. Now, it's very important that we define both of these, because the voice traffic gets priority over the data traffic. So we forward real-time traffic, such as voice, over bulk data transfer, such as emails and file transfers. So basically what happens is we set up a voice and data VLAN on the same port, and it does a little funky automatic trunk just between the switch port and the VLAN of the switch. Because within the IP phone, if it's a Cisco IP phone, it actually has an inbuilt switch in it, and the data from the PC is coming in, and then it is being tagged between the actual switch within the phone and the switch in the cupboard. So there's a de facto trunk line between here, which will come a little bit clearer as we get into it. we do some funky stuff with voice VLANs, basically. So a voice VLAN has assured bandwidth, high priority and quality of service mechanisms. It avoids congestion because it has priority traffic. It has to have a delay less than 150 milliseconds. And we need the entire fabric of the network to support voice and to give it priority traffic. So how does this work for VLANs and switched virtual interfaces? Now, as we said earlier, we operate at layer 2 and only have the switched virtual interfaces for remote access. So everything comes out of the box, VLAN 1. Then we assign individual switch ports to their VLANs. So in this case, we've made VLAN 10 and VLAN 20. And we've given VLAN 1 an IP address. So we've gone into the interface VLAN 1, given an IP address, subnet mask. Done the same for VLAN 10 and VLAN 20. Now, not all of those addresses are active because, as you can see, our protocol stack is only sitting above VLAN 1. So when we change to VLAN 10, that becomes the active layer 3 stack. And these two VLANs have their IP interfaces shut down. And if we switch to VLAN 20, that becomes the active VLAN, and VLANs 1 and 10 are shut down. So just to make sure, we can only have one active VLAN as far as IP traffic is concerned on a standard layer 2 switch. The active stack becomes the de facto management VLAN. So can we have VLANs running across multiple switches working together? Yes, we can. To do this, we connect these switches together with a trunk. Now, a trunk is where we combine traffic together. So all the traffic from all the VLANs come together to travel across the same piece of cable. And the most common trunking protocol that is used out there is 802.1q. Okay, that's the industry standard. There are other trunking protocols out there, but that's the most common one. So without VLANs, when a broadcast is sent, all devices connected to all the switches receive the broadcast. With VLANs, only the broadcast within the network. So if VLAN 10 PC1 sends a broadcast, it only goes to switch 2. Switch 2 doesn't have any other devices on VLAN 10, but there's a trunk going up to switch 1 which has VLAN 10 in it, so it travels up there, down to switch 3, and it broadcasts out to every other device in VLAN 10. VLAN 20 devices do not see that broadcast. So how does it work? When traffic is about to travel across a trunk, the trunking protocol inserts a little tag between the source MAC address and the type length field. And this contains the type of protocol that is there, the priority value, the CFI, which tells it whether it's a token ring frame on site, inside an Ethernet. So we can mix two topologies types together. And then the last one is the VLAN ID, which is 12-bit identifier that we can support up to 4096 VLAN tags on. So every frame that goes across a trunk, except for the native VLAN, has this tag inserted into it. So in a graphical representation of all that text, okay, we have host A wanting to send some traffic to host B, and we have our 3 VLANs configured on both our switches. Switches are connected via a trunk using 802.1q. So let's get on with it. So A to B frame comes in. Okay, it's coming on a port F01, which is a member of VLAN 10. To get to B, it needs to go across the trunk. So the trunking protocol goes, you're a member of VLAN 10. I better add a tag to you. So in this, we're color coding, but as you saw, it's actually the VLAN ID and all that other guff that gets added in there. It then gets placed on the trunk, travels across the trunk to the other switch, which the trunking engine picks it up, looks at the tag to find out what VLAN membership it belongs to, and then puts it on VLAN 10 and works out that destination B is on port 6 and sends it across. No other VLAN sees that traffic at all. Now, the other things that the trunking protocol or trunk engine control are spanning tree protocol and VTP and other management protocols across the trunk to make sure the trunks and everything work the way they're supposed to. And they just communicate between the engines. They don't propagate through the rest of the network. So there's a little bit of a graphic interpretation of all that text for you. So tagging, as I said, is done on all VLANs except for the native VLAN. And the native VLAN needs to be defined at each end of the trunk. If they are not defined the same, you're going to have what's called a VLAN mismatch. So you're going to have errors occurring within your network. Okay. You can have different native VLANs on different trunks. So it doesn't have to be the same native VLAN across all your trunks. It's just you're defining it from point A to point B. Each trunk is an A to B link. You need to define a native VLAN for this source and that destination on each trunk, and they must match. So native VLAN concepts. So as we can see here, we have VLAN 1 and VLAN 20. VLAN 1 is our current VLAN. So it is up and protocol is down, because we're assigning a port 3 to become a member of VLAN 99, and that is now the management VLAN. Now, as a general rule of thumb, especially in all the labs and that, you'll have some easy way of identifying the network IP address with the assigned VLAN ID. That's just for personal ease of recognizing that IP address range belongs to this VLAN. Generally speaking, unless you're in a very large network, you wouldn't have 4,000 VLANs, for example. Although we can support those tags, most lower end switches will actually only be able to manage a much lower number of concurrent VLAN IDs. So, for example, only a couple of hundred at a time, not thousands, but it supports the range of IDs. Alright, so without having our traditional our traditional method used to be, for each V network you needed a separate cable. So in this instance here, we have a separate cable connected to VLAN 30 and a separate cable connected to VLAN 20. And then with trunking, we can get rid of the individual cables and replace it with a trunk. And that trunk line can now handle traffic for all of our VLANs. And we define which is the native VLAN, which has no tags, and all other VLANs are tagged across that trunk. Now, the benefits of trunking when we're connecting to a router is routers do not have the same port interfaces density as what switches do. Your average switch has 24 ports. Your average router has 2 Ethernet ports. Okay, so straight out of the box, you've got one that basically connects to the internet and one that connects to your inside. So we need a way of saving ports on routers, and trunking allows us to only use one port for multiple network connections into the switched fabric. Now, as I said before, we do some funky stuff with VLAN tagging for voice, and here's a breakout of the IP phone. So within the phone, it has a 3-port switch. Port 1 faces the traditional layer 2 switch. Port 3 connects to our PC, and port 2 is an internal port where our voice VLANs attach. So any traffic generated from the IP phone connects to this port via port 2 and becomes a member of our voice VLAN. So all traffic coming via the voice VLAN are tagged our data from our PC is native traffic. It's not tagged, so it arrives as native traffic on port on switch 3 and is joined to whatever VLAN is attached. In this example, it's VLAN 20. And because our voice traffic has already been tagged, it'll behave as a member of VLAN 150 from this switch S3 up. Now, because we're dealing with voice, we need quality of service as close to the source as we possibly can get it, so that we can give priority traffic for the voice. Now, if it's a Cisco IP phone, we automatically detect it using Cisco's Discovery Protocol, CDP. And it sets up all of this fairly automatically. So, back to our previous example, we've got VLAN 30, VLAN 20, management VLAN 99, and our default VLAN 1. So we've added IP phones into the mix. So we're making them voice VLANs compliant, so they get tagged as VLAN 150. And there's a little trunk basically working between the IP phone and this switch port. And this switch port is doing two functions. It's running as a trunk with a native VLAN of 30 and a tagged VLAN of 150 on it. So the trunk is using 802.1q and the PCs are untagged, they're native traffic across that individual trunk, and then works as its own thing from that point on. With the configuration of it, it will come up under show interface, the interface number and switch port, and what you're looking for is access mode. It'll define which VLAN is data VLAN and your voice VLAN. It'll tell you which trunking VLAN is native. So all this information is there. Now, please note, you need to define switch port because we want to see the layer 2 information. So layer 2 interfaces are known as ports. So switch port tells it layer 2. Alright, ranges, as I said before, are basically up to 4096 IDs is valid, but we have our normal and extended ranges. So up to 1005 are part of the normal range, 1006 onwards are part of extended VLANs. Now, VLANs that are reserved and cannot be deleted are 1, 1002, 1003, 1004, and 1005. So the last 4 of the normal range are default specific to a function. So you've got FDDI, which is fiber optic connections, token ring. I can't remember what TRNet, but so you've got the it'd be token ring net and FDDI net which would probably be the management and the data. I haven't done, so basically the old token ring used to be on coax cable, and it was basically updated and replaced with the fiber optic connection, and you basically have a send and receive ring around it, so it's a double ring. So basically we can assign addresses within both ranges. Just be aware that there are 5 reserved legacy VLANs and they cannot be deleted. All your VLAN configuration is configured and stored in VLAN DAT file, which is located in the flash. And if you need to reset a switch and purge the information on all your VLANs and that, you must delete the VLAN DAT file from flash and reset your device within 5 minutes. Okay, there's a counter. Every 5 minutes, all your VLAN data is saved and updated in the VLAN DAT file automatically. You can be unlucky, delete the VLAN DAT file, then go to do your reboot and it's done an auto-save back to your VLAN DAT. I've seen it happen a couple of times over the years. You've got to be pretty unlucky though. Okay, so how do I configure and create VLANs? Well, it's very difficult. You go into global config mode, you type in VLAN 10, and if you want, you can add a name to the VLAN, and then end and save your config. Guess what? You've configured a VLAN. Now, that VLAN doesn't have any ports assigned to it. It's just the VLAN has been created. So the VLAN ID is what is actually used in the trunking system. So the number. The name is for us humans to sort of tell us what that VLAN's for. So whether it's a voice or specific data, like HR network or something like that. That's what the name's coming for. So here we have VLAN 20 being created with the name student be attached. So this is going to be the virtual network that all the student PCs connect to. So again, we've just created the VLAN. We haven't assigned any ports to this VLAN yet. So it's been created, but it is not active. Now, we need to configure the ports to be members of the VLAN. So again, global config, go to the interface, set the switch port mode to access, then switch port access VLAN, and we assign the VLAN membership using this command. Switch port access VLAN, and then the VLAN ID that we wish to be a member of. Rinse and repeat for all of your port members for that group. So in our example, we're attaching the port F018. So we're switch mode, access VLAN 20. We've now attached fast Ethernet 018 to VLAN 20 on switch S1. So how do we configure a voice VLAN when we add a phone into the same port? Well, when we go into the configuration, we are just going to add our little mode in. So we create the student VLAN. Okay, VLAN 20, name student. Then we go VLAN 150, name voice. Go to our interface fast Ethernet 018, switch port mode access, switch port access VLAN 20. Then we do the quality of service command, MLS, quas trust cos. So that's quality of service trust. Cos is the type of quality of service markings used in layer 2 traffic. And then we add switch port voice VLAN 150. So it knows now that it's going to tag and trust the tags for switch port voice VLAN 150. If you do this, most modern switches, when you put switch port access VLAN 20, if you've forgotten to create the VLAN first, most modern switches will automatically create the VLAN if it doesn't exist when you type in the switch port access VLAN. Okay, it's not the best process, but it's available. Two-thirds of the way through, guys. Alright, to verify, we do the show VLAN summary, which gives us a summary of how many VLANs there are. Or we can do a show interface VLAN 20, and that will tell us whether the VLAN is active or not. Now, with port memberships, if we do the show VLAN brief, it'll come up with all our VLANs listed and all the ports associated with the VLAN. So when we use the switch port access VLAN and then the VLAN number, we're making an association between the port and a VLAN. To remove all of those associations, you can turn around and say no switch port access VLAN, and that'll default it back to the default VLAN of 1. When you wish to reset it, remove all your VLAN configuration, you must delete all the VLANs from the VLAN DAT file after you remove the VLANs with the no VLAN and VLAN ID command. So you delete it from the configuration of the switch, and then you need to delete the flash VLAN.dat file and reload the switch. You need to do this in quick order because, as I said, the VLAN.dat file is automatically updated and restored periodically. How do I configure a trunk? So, like the switch port mode, instead of access, we turn around and say it's a trunking port. We then specify what the native VLAN will be across the trunk, and we can then specify what VLANs will be allowed to travel across the trunk. By default, it's all. So if we do not specify a allowed VLAN with that command, all port VLANs will be allowed across the trunk. So in this example, we have VLANs 10, 20, 30, and 99, and we have a trunk between S1 and S2. So we go into the interface FA01, switch port mode trunk, switch port trunk native VLAN 99 being our management VLAN, and then we're going to allow switch port trunk VLANs 10, 20, 30, and 99. Now, some models of switches require a slightly different order of command structure. So just be aware that that's the most common order. It's just a couple of old ones that require a slightly different order. So when we have a look at the interface, type in the commands, switch mode trunk, no, again, to remove any command, we put no in front of it, and then show interface FA01 switch port would give us all the information required about that layer 2 interface. In this case, we're saying it's a trunk, and need to go back. It's using .1Q encapsulation, and the native VLAN is 99. And down the bottom, trunk VLANs enabled all. So we can reset it with the no commands. Remember, no switch port trunk allowed VLAN, no switch port trunk native VLAN. We'll default it to native VLAN 1 with all VLANs being allowed. Removing the trunk and turning it back into a standard data port, we just turn around and change the mode to access. And that will change it from trunk to access. So the switch port mode command, the last one entered, is its current state. All right, dynamic trunking protocol. This is the last bit of info for this morning. This is a prior Cisco protocol used in its Cadillac switches to manage the trunks, and it can be turned off if you need it to. But what this does is it allows it to auto-negotiate the encapsulation and that on each end of the trunk between the two switches, so you don't have to do as much manual configuration of the trunk. So what are the elements? Access, dynamic auto, dynamic desirable, and trunk. So if we say switch port non-negotiate, we're going to turn off the trunking protocol. If we say access in the option of switchport mode. We're putting it into permanent access mode. Dynamic auto becomes a trunk if the neighbor is either set to trunk or desirable mode. So if you have both ends set to dynamic auto, it's not going to form trunk. One end must be dynamic desirable, which means it's actively trying to negotiate a trunk, or trunk. So it just removes one element. Personally, I tend to just manually set the trunk, because that way you know you've set it and you've configured it. So from this table you can see what combinations will give you what. So dynamic auto and dynamic auto will give you an access trunk port. So just read it across to get the combinations and what the result will be. If you cannot remember this table, do not use dynamic trunking protocol on your ports, because you may not get the result you want. So to find out what's going on, show DTP interface and it'll tell you what's happening with the port as far as the dynamic trunking protocol is concerned. So as it says, best practice is to set the ports to access or trunk and turn dynamic trunking protocol off. Now, the good thing about these chapters is that every chapter has a series of packet tracer activities and lab files for you to complete, which obviously I'm not going to go through step by step. You can follow the instructions and do the labs on your own, but I highly recommend you do them because it cements these concepts into your mind by actually doing them. And don't get concerned if you make a mistake during them. I personally have gone through, done labs 100% following the instructions. They worked fantastic. Guess how much of that lab I remembered? Not very much. It's when I make mistakes in my labs and have to fault find, I remember more about the protocol and how it behaves than when I did a perfect copy and paste out of the lab files. So don't be afraid to make mistakes during labs. They help you learn. Okay, so in this module we had a discussion about what VLANs were, how they segregate the networks into function teams or applications based on whatever logical function we want to assign. Each VLAN is considered a separate network. We use trunks to configure point-to-point links between switches that can carry multiple VLANs, optimizing our physical infrastructure. We had a look at the trunk protocol that keeps our traffic segregated whilst over the trunk. We had a look at the various different types of port assignments, being data, voice, trunking, how to configure them, how to erase them, and that's it in a nutshell. not quite. Trunking tagging. Oh yeah, we talked about that. Dynamic trunking protocol, not good. Disable it. Manually set access and trunk ports. Now we're done. And I slowly move the mouse up to the stop the recording and shut up mark button.